Hey everyone, in this video we will learn about variables. First I will explain you what are variables, then I will teach you that how you can declare the variables. After that we will discuss about the precautions that we need to take care of while declaring the variables. And then in last we will create our second project to understand these elements a little more. So again it's a really easy concept like the constants and also an important one. So let's begin with what are variables. So variables are the containers to store the data in a code. Like in our LED blink project, we have declared pin number 3 by using int LED1 equal to 3 and then a statement terminator. Here 3 is our data and this LED1 which is storing this data is a variable. And not just the pin numbers, these variables can store anything. Like I can store int LED2 equal to 500. Here we don't have any pin named 500. It's just an integer number. You can also store some character values. For that you need to use char LED3 equal to, let's suppose we have ME. Then these quotes and a statement terminator. Now here these int char, these are the data types about which we will learn in the next module. Right now our focus is these variables. Now here this M is also a data in our code which is stored in LED3. You can also store floating point values like 500.4, something like these. So these are the variables. And now after the variables, how we can declare these variables? So as you have already seen, we just use a data type, then a name for a variable, then equal to, and then some data in that. Now this is how we declare the variables. There are a few more things about these variables, like where we need to declare these variables and what data do we need to add and is it necessary to add the data. So first of all, let's discuss about the position. So here we have declared this variable in the beginning of the code before all these functions. But you can also declare the variables inside any function, like here int x equal to 2. So I have declared that variable here. Now what's the difference in between these two? The variable that is declared initially can be used anywhere in the code, but the variable declared inside any function can be used only inside that function. Like if I have any another function here like void add, let me create a function here, then these curly brackets, and inside that function let's add this variable LED1. So to use any variable we can just write their name and it can be called there. So LED1 and then statement terminators. Now if I try to compile my code, then you will see that there is no error in the code. Here we have done compiling. So we have declared that variable here and used that one in this function. You can also use that same variable inside the void loop function. Like here we have LED1 again and then a statement terminator. So now if I try to compile my code, then let's save this one. Then you will see here we have done compiling. Now what if I try to use this x in void add? Then let's see what will happen. So here if I try to call x, so here we have x and then statement terminator. Now if I try to compile my code, you will see x was not declared in this scope because that is declared inside only void loop. I can use that one in loop here, and let me remove that one from here. Now if I try to compile my code, you will see there is no error in the code. Here we have done compiling and here we have called x. And this is how we can declare the variables at different positions. Now after this, let's talk about the data. Let me remove this whole function from here. There we go. Now here we have provided this a 3, which is a pin number. And I have told you can also provide an integer value, any character value or any float. And you can also declare empty variables like int x and then statement terminators. And then later in the code, you can assign some value to it, like x equal to 2. There we go. Then a statement terminator. And if you check this one, so here we have this one done compiling. So it's a valid way to declare the variables and provide them some values. And you can also declare multiple variables with a common data type, followed by a comma there, like int x, then I have y, and then I have z. There we go. And if you try to compile again, you will find no error. This is also a valid way. You can also provide data to any of these and left others empty. So all these are valid ways to declare any variable. Now after these, what are the things that we need to take care of while declaring the variables? So we only need to take care of the names, that what are the names that we are providing to the variables. Like here we have provided LED1. It includes some alphabets and a number. So there are some rules here that we need to take care of while creating these names. Here first one is you can use any alphabet in that name, like LED1 and then something like this one. Let me remove that one from here. So any name that includes alphabets is valid. Let me show you that one. So if I try to verify this one, there we go with done compiling. You can also use any numbers after these, like something like this one or like this one. And again, if you try to verify the code, you will find no error in that one. All this is valid. But you can't use a number before the alphabets, like one LED. In that case, that will not be a valid variable. Let me show you that one. So if I click on verify, you will find their error, which is expected unqualified ID before numeric constant. So this is not a valid way to use any number before any name. So make sure if you are using the numbers, you are using them after the alphabets. However, you can do something like L1ED. That is a valid way, but not one LED or any number before it. And after this, the third point here, you can also use capital letters like L, E and D, all in capital. So if I try to verify this one, you will find that this one is also a valid way. Now any name including only alphabets, whether they are uppercase or lowercase, is valid. And now after the alphabets and numbers, let's talk about the special characters. So you can't use any special character like @ or hashtag or any special character in your variable name. In that case, you will find error because that is not a valid way. Neither you can't use them before the alphabets like this one. In that case also, you will find some error. The only special character that is allowed is an underscore. There we go here, LED_1. In that case, it will be a valid variable name. So make sure you are not using any special character, expect underscore. And why only underscore is valid here? Because it's an alternate to space. You can't create a variable name with any space like LED space 1 because that's also not valid here. So these are the things that you need to take care of while declaring the variable names. First one is you can use any alphabet, whether uppercase or lowercase. Second is you can use numbers but after the alphabets, not before them. Third is you can't use any special characters, expect underscore. And the last one is you can't use a space between any of the elements here. So this is all about what are variables, how we can declare the variables, and what are the precautions that you need to take care of. So as I have told you, this is really easy concept. There is nothing complex about it. Now after this one, let's create our second project to understand the variables and also the constants a little more. So let's have a new window here and hide that one. There we go. So what we are going to do here, we will take 3 LEDs, turn all of them on, and then one by one, after a half-second delay, turn them off. So we will use this example to understand the concept of variables and also the constants a little more. So first of all, let's try to understand this circuit diagram, then we will create a code for our project. Now here, before understanding the circuit diagram, let's understand the concept of ground pins a little more. So as you know, ground pins are just the negative terminal of any circuit. On our Arduino, we have 3 ground pins, 2 here on the power side and 1 on the digital pin side. So only 3 ground pins but 14 digital pins and 6 analog pins. So how we can complete all these circuits with only 3 ground pins? What if I have 12 LEDs here? In that case, we need to make the ground common. We can use a common ground for multiple elements because as I have told you, it is just the negative terminal of any circuit. We don't provide any input or output value to any of ground pin. They are just used to complete this circuit. So that's why what I have done here, I have connected the positive terminal of these LEDs to pin number 3, 4 and 5 using some resistors and a breadboard. and the negative terminal of all these LEDs is connected to this common ground. I have used a common lane of my breadboard to first make these a common connection, then I have connected it to a ground pin. Here you can see I have used this long wire to connect this negative terminal to this line, then the negative terminal of my second LED again to this line, and then the negative terminal of my third LED again to this line, which in turn is connected to this black wire. So this is the circuit diagram for our project, and I also want you to use a common ground because in this case we have 3 LEDs, but we are going to use more than 3 LEDs very soon. So you need to make a habit of using a common ground. So let's create our code now. So first of all, make some space here. There we go. And keep this one here. And let's minimize this one. There we go. Now first, our objective is to make these LED glow and then make them turn off one by one after a half-second delay. So first, let's declare all of these, and for that, just write here int, and let's name these ME, RON and LED1. So first we have ME equal to 3. So this is just to make you know that how flexible are the variables. Now after this we have int RON equal to 4, and then we have int LED1 equal to 5. There we go. Then the statement terminators. Now after declaring the pins, let's set up these pins. So for that, use pin mode, and inside that one ME, and we will use all of these as output pins. So write here output. There we go. Then a statement terminator in last. And now let's copy this line instead of writing it again for RON and LED1. So Control C and Control V, and then again Control V, and now change ME to RON and then ME to LED1. There we go. Now we have set up these pins, and now let's move to our main code. So here first what will we do? We will make all these turn on and then use a half-second delay to turn them off one by one. So first write here digital write, and if you got what we need to do here, you can just pause the video, write the code by yourself and then check it with me. So here digital write, first ME high. There we go. Then a statement terminator, and now again copy this line to save some time here, and again paste it twice. So Control V and Control V, and then change ME to RON and LED1. There we go. Now here at this point all of our LEDs are glowing. Now first we will turn ME off. So for that, first provide a delay of 500 millisecond. Then we will make the ME turn off. So digital write ME and then low. There we go. Then statement terminators, and then after another half-second we'll make RON turn off. So for that, again write delay 500, then statement terminators, and then digital write. There we go. And inside that one, RON turn off. There we go. Now after that one, again the statement terminators. So I hope you're understanding what I am doing here. Now at this point only LED1 is glowing, but ME and RON are turned off. Now provide another half-second delay. There we go, 500, and then turn off LED1. So just write here digital write LED1 low. There we go. Then a statement terminator in last. So at this point all of our LEDs are turned off. So here we are done with our objective. Then in last, provide a 1 second delay so that they remain turned off for a second, because as you know, once this command is done, the while loop will again run the code. So to prevent that one, provide a 1 second delay here. Now this is our code. Now let's try to upload this code on our board and see how it will work. So here we are on the board, and for this project we will need our Arduino, one breadboard, 3 connecting wires which are of different sizes, 3 LEDs, 3 resistors, and 4 male to male jumper wires. Now let's begin with our LEDs connections on this breadboard. So for that, we will first use these connecting wires to make the verticals line common and make a common ground line. So you can see here, these are just metallic wires which I have cutted in different sizes. And also it's not necessary that you must use these. You can directly connect the components. I just use them to make the circuits look more cleaner. Now here I will use this line as a common ground line. So I will just insert one end here and the other on a different vertical lane, just simply like this one. Now similarly, connect the other two connecting wires, which are a little hard to grab, and insert these just like the first one, as you can see here. And then in last we have the third one. Now let me connect that one also. So there we go. Now here I have used this line for my common ground reference as in our circuit diagram, and then I have joined this vertical line, this vertical line, and this vertical line with this one. So now at this point, these 4 lines, all of these are a common connection right now. And after this one, we will connect our LEDs. So here we have our LEDs. Now let's find out the positive and negative terminals. So here in this LED, this one is our positive terminal. So we will connect the negative one with the connecting wire and the positive one here. Now similarly, we have this second LED with the negative terminal here on the right. There we go. So just connect these. Similarly, we have the third one, and here we have this one negative terminal. There we go. Now as you can see here, all of the negative terminals are connected with these connecting wires, which are all linked here in this lane, as you can see here. Now after this one, we will use the resistors for protecting our LEDs. So here we have the first one on the positive terminal of this LED. Similarly, we have the second one here and the third one here. There we go. So this is our circuit connections on this breadboard, just simply like this one. Now after this one, let's connect the ME, RON and LED1 to our Arduino. So we will use these jumper wires here. Now first, let me connect ME. So here we have the ME on pin number 3. So here we have 0, 1, 2 and 3. There we go. Then we have RON here, which will be on pin number 4 of our Arduino. Then we have LED1. There we go. So this one on pin number 5. Let me show you a little more closely. As you can just see them here. Now after this one, we have the ground pin in last. So here connect this one in this vertical lane and then insert it in the ground pin. So these are the connections for our project according to the circuit diagram. And now let's power up the Arduino and see that how our project will work. So here I have my USB cable. Now just insert that one in the USB port of the Arduino. And here we have our project working completely fine, as you can see here. So first all these LEDs are glowing and then one by one they are getting turned off. So here we have first the ME, then RON and then the LED1. Let me show you a little more closely. As you can see here, so this is our second project, and again I hope you got the same results, and in case if you are not getting the same results, just ask the questions. Now after this one, I want to show you one more thing here in this video, that what if you want to power up the Arduino without using this USB cable. So I will show you a method by using a 9-volt battery. So for this one, you will need a snap connector in which we have a battery to barrel jack. So just simply insert this one here on this battery and then plug it into the barrel jack. There we go. Now as you can see here, our project is working completely fine, just like with the USB cable. So this is how you can also power up the Arduino without any computer or any USB connections. So this is all about our second project. Thanks for watching, and I will see you in the next video.